Okay, so this is just going to be a slightly longer class to look at how to clean up and deal with CAD files. We often receive these really sort of big CAD files with a lot of stuff going on, and we need to clean them up and associate them correctly so they work nicely within Revit. So in order to clean up these files and get them as neat and tidy as possible, we really want to look at all 6 of these steps. We'll look at the scale the drawing's at, the orientation, whether it's orientated to true north, the actual origin, the 000 point of the file, the layers that are used in it and whether they've been appropriately used, what height both the elements we want to be at height, like the contours, etc., what height they're at, and also if there are any objects that are at a unusual height. And then we want to be able to WBlock out the elements that we are happy with at the end to minimize file size. Okay, so we're going to start by doing just some general cleanup on this file. There's 2 instances of the group here. You can see even just selecting that group, CAD freezes for a little bit, it's a bit slow. So we're going to delete that. Often surveyors have that or other blocks or templates around here that we can clean up and delete. The next thing we're going to look at is the scale. So that we can get the scale of this drawing firstly by, if you look at the scale bar over here, that's usually just going to tell you what scale it is in the paper space. That doesn't really interest us. We need this scale in model space. Typically it's in meters, but it's worth checking. So I'm just going to delete that. Use the distance command to check the length here. You can see it's 42.64. It's also what it says up here. So that's going to be 42.64 meters. So we know it's not in millimeters or centimeters or anything like that. Now we're going to check the orientation of the plan. This one's relatively simple. It's just marked as north. It's pretty safe to assume that this is true north. You will see on some plans they've marked both true north and potentially magnetic north or a MGA north or some other north point on here. For the purposes of Revit, we generally want our plans to all be orientated to true north. If you've got any questions about that, just see your BIM manager about what's appropriate for your particular area, but most surveyors will provide it to you in true north. So the next thing we need to check, which is pretty important for this, is the origin of the file. The origin that's used is going to be one of the biggest issues we need to fix for Revit. So we can have a look in here, and these surveyors have been nice enough to actually say what origin they've used. Coordinate origin is at a particular location, and it's on an MGA azimuth. Distance is a plane, which is great. Easiest way to find the origin is to just type in line and then go 0, 0, 0, hit enter. You've now got a line going from the 0, 0, 0 point, and we will connect that to, I'm going to sort of just pick a point over here and say that is my local datum. So we can see that's where the CAD origin is, and this is where our geometry is. Now for Revit, this is too far away from the origin point. We need to get all this geometry down to that other origin point at the bottom. So we can delete all of this stuff. That's not important. And what we want to do before we really move any further is we want to label here what the actual what that origin is equivalent to, so that in Revit we know how to locate this point. Now if you click on the line that you've just drawn, you can see that the X and Y are essentially equal to your eastings and northings from this point. So what I like to do is to drop in a little bit of line work and some text to actually notate where that origin point is, so that it's nice and clear for everyone using this file. What I can find though is often surveyors don't have very good fonts in their file, so I can just fix that in the style here. Now I've just used standard and just change that to Arial. Sometimes you do need to click on it for it to refresh, type refresh, and then it's going to look a bit nicer. So I leave this here so that in Revit you can refer back to this point and double check that it has the correct coordinates. It's not a terrible idea to put this same thing in for like another point on the file, and that'll allow you to check rotation as well as location. You're probably asking, why did I pick this point? I picked it because this is pretty much our site in purple, but these lines in between are currently non-confirmed. So this point here, which was a definite boundary, an existing boundary, is a known point in space. If you've got a more detailed survey that has a surveyor's point marked clearly, something that's easily reproducible on site, the ideal location is for this would be about here somewhere where everything on the site is a positive number in the east and the north from that point. That's not super critical because generally we're going to measure everything to the survey point origin anyway. The important thing is that the local datum that you're using is something that can be reproduced by a surveyor with relative ease. So I try to stay away from like a screw-in curb or some sort of site feature that could potentially be demolished, and something that's right in the middle of the site that's going to be in people's way. You want it to be off to the side and easily reproducible for all of your consultants and any other surveying work that needs to be done. So the next thing we're going to talk about is layers. If we talk about, type in LA for layer, you can open up the layers dialog box and see all of the layers. We can see if any of them are frozen or turned off just by looking through there. We also want to see what are the naming that's used. Are there a lot of layers? Is this like super long with 1,000 layers? The reason we need to check this is mostly because we want to make sure there isn't a huge amount of geometry in this file that we can't see because it's turned off. So the best way to turn it back on, I find, is to just type in lay on. That turns on all layers that are turned off, and lay thaw, that will unfreeze any layers that are frozen. If you have turned on some layers that you're not interested in, you can always hit Control Z to undo and turn them off, or go back and turn them off in the layer dialog so that they won't be in the finished product that we're pulling into Revit. Okay, so the next steps here is to get the geometry we want to be in the right position and at the right scale. So I'm going to do a left click here to grab all of this geometry. Alternatively, it's nice if you zoom right, you can go Control A for select all. You can then use your Shift select to get rid of this line. I'm going to type move the specified base point. If you hold Control and right click, you can nominate a snap as well, and that will make sure you're happy with where you're going. Basically going to move all the geometry from that end of the line to the other end of the line. Now if you zoom in here, you should be able to see that there's no longer anything at the end of this line. It's all now associated. So what we've done is we've made the CAD file origin 000 at this point, which is essentially our local origin, and then we've recorded how that point relates to our survey point. So now we just need to get everything to the correct scale. I'm going to click everything that's here. Actually, Control A, and going to SC for scale. Again, specify that endpoint, so we're going to use that line, and I'm going to bring this up to 1000. So now my file is in millimeters rather than meters. Now you can scale these things as you bring them into Revit, but it's much better to actually get them in a 1:1 millimeter scale in model space before you bring it in, and you won't get this weird parallax error in Revit where as you zoom in the lines jump around and move on you. So I highly recommend putting them in true millimeters in CAD rather than linking them in and scaling them on the fly. You'll get a much better result. Now, one of the other important things to check to make sure this isn't outside the maximum allowable radius within Revit is both in the X and Y and in the Z direction. So I'm going to do a zoom all just to see what's happening. It looks like there seems to be something out here that's causing that to not just fit nicely around just our geometry. Sometimes this could be the origin of a block, or it could be this group, for example. I'm going to ungroup that. Zoom all. See if I can find what it is that's up here. The other thing I always like to do is to have a look at this from the Z direction. So you need to make sure that everything is at the heights. If you've got contours, etc., that they're actually showing up at the correct levels. You can see here we've got a lot of geometry that's just oddly at a different height. You can flatten these objects out. Some quick ways to do it is by picking something like circles. You can change the Z center to 0, get everything back down to 0. You can sort of pick all those objects and work through them one at a time. So you go to all the circles, make all the Z centers 0, all the M text, and make it Z position 0, that kind of thing. You know, you can essentially do that with any of these items. The other thing you can do here, if you've got lost objects you're trying to find, if you do a bit of a window select there, you can see you've got 7682 is that number. If you go Control A, that's selecting everything in the file. You can see you've got 7685. So see, there's 3 objects that are just not part of that selection. They're just a bit of text that's got a really big okay, yep. So that text has its origin way over here, and that's potentially what's causing that zoom to look funny. So you can have a look at those 2 pieces of text and see if they are valuable. I'm just going to delete it for the purposes of this. We go back to the top now, do a zoom all. Now you see that the zoom all fits nicely within here. We should be able to check the same thing from the front. So if we do a zoom all, yeah, everything fits pretty nicely. It's not. If it was like this, you could see there's some object up here in the Z space. Sometimes when you're getting those issues, it's the origin point of a block. So you may need to explode all the blocks within the CAD file. And the final step here, and one of my favorite parts of this, is WBlock, which stands for right block. Basically, you just select the objects that you want. You'll notice I'm using a crossing window select. You can select this way and it's going to select everything it's touching. I'm selecting this way to just get the objects I'm interested in. I'm then typing WBlock, and it's going to bring up a dialog that will allow me to essentially save just those geometry I've got selected out to a new file, and this will take with it only the layers, blocks, etc. that I've selected. So it's going to give you a very clean file, much better than trying to purge stuff out of this file. So then I just need to go and select where I want to save that. I'll go and save it wherever. I can leave the insert units as millimeters. I can leave the base point as 000 because we've already set that up. It doesn't really matter what I do to the geometry in here, but yeah. I'll just hit OK there, and it will save my file out. Now here is the file that I've saved out, and it's all nice and neatly finished. And you can also see from the file sizes that this is significantly smaller than the original.